My name is Brad Coogan. I'm the editor of Metal Forming Magazine, and I'm pleased to serve as your moderator today. Since today's GoToMeeting session is being recorded for archiving, all participants are in listen-only mode. The speaker and the other listeners will not be able to hear any audio from your site during the program. However, you do have the ability to communicate with us throughout the program by submitting any questions using the question box, which is in the right-hand control panel. Simply type your question to an organizer as selected from the drop-down menu. And at the end of our presentation today, we'll have some time for a Q&A. I also want to let everybody know that a link to the recording of this event will be available within the next few days on our website and on the website of Seyi as well. And you'll be able to view the program again and share it with others at your company. Also, before we get started with the webinar, I want to invite everyone to attend the remaining webinar on our schedule as part of this series, which takes place next week, September 18th. And I also hope you'll consider attending our live half-day conference on Servo Press Technology on Tuesday, October 7th in Nashville for additional opportunities to learn about servo technology and to network with thought leaders throughout the industry. More details on the third webinar and on the live event are available on our website, metalformingmagazine.com/servo. Now it's time to begin today's webinar. Presenting for us today are Randy Kish, Regional Sales Manager for Seyi Presses, and Nader Lalinja, President of Finstans Teknik, a Swedish tool and die maker. Randy Kish has been involved in the metal forming industry for nearly 15 years. Is currently in his 5th year with Seyi, and Nader represents Seyi Presses in Northern Europe and is part of the Seyi European team. As part of his die design and build services, as well as design optimization, prototyping, and tryout, Nader runs a Seyi SD1200 direct drive servo press. So today, Randy and Nader are here to discuss the gap in servo technology knowledge that exists among part designers and tool and die makers, and the opportunities to fully leverage the capabilities of servo presses by closing that knowledge gap. So please welcome Randy Kish and Nader Lalinja.
Well, thank you, Brad, and good afternoon, ladies and gentlemen. Thank you for taking some time out of your day to learn a little bit more about servo press technology. I am Randy Kish, and I'll be walking through this presentation, and Nader is dialing in from Sweden right now, so he's going to be here for some support and possibly being able to elaborate and be able to answer some of the tougher questions. By no means am I a tool and die designer or a part designer, but what I've been noticing is just kind of going through with our customers and such, there still is trying to grab an understanding of looking at things differently with the servo technology, you know, how it applies to the design process. And as Brad mentioned, we're trying to sort of bridge that gap a little bit. Before I get started, I just want to acknowledge today is September 11th, and just kind of position everybody that, you know, something that we want to keep remembering. I do, going back to my days of PMA, I remember walking in a month after I was hired and having this happen and pretty much everything coming to a standstill and wondering if I was going to have a job at that point. So we've come a long way in the last 13 years. So in this presentation, what we're going to discuss, you know, a lot of it will reinforce things that you already know. Again, as part designers and die designers, picking this particular topic, or, you know, positioning it as part design and die design with servo presses, is really making sure that we attract the attention of the most important people that need to listen to the servo technology, to understand the servo technology. So I hope that we've accomplished that. And as we go through here, just walk you through some basic forming review, take a couple minutes to do that, and then go through the servo control basics. I'm going to skip a lot about the actual servo press technology. I'm kind of going into this with the assumption that many of you kind of understand the flywheel replacement, you know, and with servo motor and all of that stuff. I don't really want to get too far involved in that. And then just kind of giving some tidbits of rethinking the approach as you're looking at the design process, and taking advantage of the servo technology as you're approaching the design work. So, you know, I look at this, the part designer, always looking for cost-effective weight savings in the design process. You know, it certainly, I'll speak mostly in experience with automotive, but you know, it's transferring to every industry. And of course, we're always looking at ways to design that part with less tolerance, closer fits. And what I hear from customers sometimes, they're tool and die makers, that maybe sometimes those part designs aren't very realistic. And then that kind of falls back down to the designer to be sort of being able to foresee how you know, maybe the gaps or understanding the material better and how it's going to form and how it may stretch, shape, and trying to work with the part designer to come to a happy medium. You know, the third thing I think we should look at here is actually nowadays with the servo press, I think the conventional way of thinking was that you design a part, you design a die, and then that determines what kind of press you buy, or what kind of press you're going to need and determine specifications. And now with the servo press, it kind of turned everything around. You know, I remember a colleague saying it seems like with the advent of the servo press, it's kind of, was the market actually demanding the servo press to be made, or was the servo press made and the market had to catch up to it? And it seems like that's what we're doing. We're actually, you know, with this new technology, we're creating a kind of a new market, and now everyone's trying to catch up to it. And that's why we look at it, Seyi looks at it as that, you know, in this process planning, you should consider the press manufacturer, the servo press manufacturer, in being part of that planning. Even if you don't, especially really if you don't already own a servo press. We hear it a lot that, hey, I don't have a servo press, so I can't sit there and try things out. You know, I'm not doing all that stuff. Obviously, we would want you to purchase a servo press, but I look at it as that the press manufacturer should have in place some way of helping a customer, or even helping a potential customer in evaluating the application and possibly coming up with some recommendations of a die design that could be optimized using the servo technology. I mean, that's a really good way of getting ramped up with the capabilities. And Nader happens to be an extension of Seyi in this capacity. His work in Europe, I guess we would call this one of our kind of our application and tryout centers in Sweden, where you know, the potential customer can come to him. They can do die tryout. He can help a customer walk through the design and offer, you know, an extended service. And I do believe that that's part of responsibility of the press manufacturer these days if we are to gain more usage in the industry. So I recommend to try and get the press manufacturer involved in that planning process. Let's start off with just some basic forming review, and I'm going to go through this very quickly. Focusing on the automotive industry, we're certainly starting to see the high-strength steel pretty much prevalent everywhere. And with your understanding already of what that means, we're even starting to get into higher strength steel with, in megapascals and that are kind of off the charts, and getting into, the transformation induced plasticity, and getting into martensite, where these materials, especially with the trip, actually hardens as it's being formed and becomes a very complicated beast to grab hold of. And what we're starting to see a lot now is people, customers, falling into these ranges of strength yield and tensile strength, getting into the 500 megapascal range. And with that, as the steel is increased, then, or the steel strength is increased, then the actual end value, or its, the work hardening exponent, stretchability, is decreased. And so with that comes the recognition from the manufacturing engineer, how these high-strength steels are going to have different forming characteristics. And so, they need to be planning for the correct material with the correct part. And what we really get down to is that then we start introducing a lot of residual stresses and elastic recovery. And as you're well aware, as you're working with these materials, they just kind of want to bounce back, and what we call spring back. This example, some testing done by Seyi has a partnership with Taiwan University, and they were doing some testing on, this is kind of using a flange die, I believe, and running it through a typical mechanical press and showing, as you're jumping up in the steel strength, how much more you're getting the curl, edge curl, and getting spring back, and how to control that. And of course, as we are talking about high-strength steels, you get that work hardening effect, and you ultimately end up, breaking the material. So what we really want to be able to try and do is, try to form that part, try to form as much of the part as possible to its full depth in the first forming operation, so that it's not allowed to harden and break on maybe the next strike. So in the past, we've looked at a lot, tool and die designers, part designers, coming up with different ways of controlling the flow, or restriking to get rid of the spring back, and designing dies that way, or putting in binders. And of course, cushions and pads are very popular to try to control that material flow. And trying to form with a high-strength steel, maybe opening up the clearances a little bit so that it allows that material to flow a little bit better. And then, here comes the servo press, and it comes along and kind of changes everything and says, okay, well, now we've kind of are attempting to take away all this, maybe making it less complicated to form these steels, because now we have control over the control of the energy throughout the stroke, and running with maybe a higher torque motor we can control the speed and control the distance, and by doing that, we can have a lot more control over that material flow. The one thing that I want to point out here, if it's not already known, is that, you know, the servo presses, no matter who it is, servo presses still have a tonnage curve, and they still have a tonnage rating point. But of course, the big difference is that you have energy. You have a you know, constant energy throughout that stroke. So even, and especially when you're working at slower speeds. And because of that, that allows us, you know, gives us the control over the forming, the operation. Now, real quick, I believe every servo manufacturer is going to allow you to control that slide position, and then your dwell time, and of course the speed at which you're forming. And you should have the capability to program set points. Seyi goes up to 20. Other manufacturers may have different quantities, and that is, you know, the control you have over one cycle of the press. So over one press cycle, you're controlling 20 points, and those points really, when you look at it in a die design, you know, it transfers over pretty transparently as to what's happening at a point in the die and what needs to be then transferred over to a program profile. So in this particular example, I wanted to give you an idea of how a program, how a profile is programmed. And this example is actually a demonstration that Nader had performed when in Sweden at his shop back this past January. And what it demonstrates is one of the motion profiles that are built into a Seyi press called vibration mode, which allows you to step down and come back up, down and up, down and up, down and up as you approach bottom dead center. And by doing this, you're controlling, what we're doing here is we're controlling this, I guess what we call this male portion of this gingerbread man, to make this beveled edge, and to be able to do it with high precision. I'm going to try to play a video for you here to see it in action, and then discuss what is taking place in the profile. So what we're showing you right here is the actual signature as the part is being made. Oops, what happened here? Okay. Let's go up one. Go over a little bit. So what we actually have here is your tonnage signature. You know, we're getting closer to forming, and then you start seeing your tonnage go up. And barely noticeable is actually this step down as it's going through and forming the part. Let me come right back up to top dead center. What we end up here then is what we're testing out here. So, you know, there's no heat coming off of this part. The heat could rub his finger around the inside of that without any burrs or cutting the finger, and then we have that pretty tight radius around the opening. And here we're describing where there's no burring or tearing. And by doing that step motion, you know, we're allowing the material to flow as it goes through, and you know, slowly bring it together without having any cracks or distortions. And the resulting part actually going on to the extruded end then fits together, you know, seamlessly together, just coming right out of the die with no extra steps needed. So what we're actually doing here is, you know, when we're setting our points for this particular die, you start off your top dead center is 250 millimeters. And so we're going to come down at a pretty swift pace. We're going to come down to 45 millimeters, and we're going to start our first step, P1 to P2, and slow it down a bit. And from this point on, what happens is that then, you know, controlling the step down instead of having to enter multiple parameters each time to get your step, particular feature of this mode, this allows you to say to it, okay, when I get done with P2, I'm going to come back over here. I need to go up another 0.3 millimeters, and then I'm going to do it pretty slowly, and I'm going to go down another 0.8 and continue doing that how many times I want to do it. Well, in this case, 35 times. So in these 35 steps, you get the resulting part. Nader, is there anything that you would want to add to the explanation of this particular part design? Possibly, you know, we're trying to demonstrate the vibration mode, but what other information could be gleaned from this example?
Hello, everyone. I am. That thing is very important because you can use the vibration. You're going up, in this case, 0.3 millimeters, and going down 0.8 millimeters. And it means when you're going up, you get the oil back to the punch, between punch and the part, and you can. What I say, you can make massage in the part and getting down, and without any crash in the part. So the shape is working very fast. The program control is very fast and working together with the servo motor. So it's for a moment what I know it's only possible in a Seyi press, what you can do here, what we do here. So it's a very important thing to know.
Nader, when you designed this die, did you have to do anything extra or extraordinary in the die itself, or is it? I mean, could you make this die? Could you make this part in a mechanical press?
No, it's not possible. Yes, you can do it in mechanical press, but you need. I think you need more than 6 steps.
More than six stages. So this would be more of a maybe 6 or more stages to complete this part.
Yes.
Okay.
So the tool is in this case is only a matrix and a die and a punch, so nothing more. It's very easy, and that is the most important thing, because using the control system, the machine control your process to do the thing you was never able to do it before.
Okay, thank you. Now, one of the, it seems to be the most popular thing when I'm out in the field is, everybody seems to understand that, while they could run things faster in the pendulum mode, I could double my throughput. And where that is definitely the case, right? And a lot of manufacturers are saying, I'm going to, purchase a servo press and I'm going to run my current dies in there and possibly get an increase in the production rate. And this is, this is a very typical demonstration of the pendulum motion. Just using a basic prog die, and of course, you're going to get the full advantage of using the pendulum motion. So what we're looking at here right now is, we're operating the press at 30 strokes per minute using a full revolution. As we're programming this in, we actually select the half or pendulum motion, and we're all very familiar with how the press works this way in a crank motion. And it really just wanted to demonstrate how easy this is to move into a pendulum mode. We're just selecting the profile, and then you're, hopefully this won't go back again. I apologize. The run button disappears, and then I don't have an opportunity to stop it. Probably could change that. So we're just selecting the half or pendulum motion from the motion select, and all we really have to do, what we're doing here in our first point, our first set point, is adjusting the, basically reprogramming the top dead center. So when we're going to put it in, we're going from, instead of doing it at 250 millimeters and going a full revolution, we're bringing it down to 70. And we're going to keep the speed at 30 SPM, which is the rated SPM for the press. And so you hit OK. That's all you really need for your parameters. Because we are running a coil feeder on this, built into the controller, are your timing switches. So you need to adjust those as well, right? Make them move a little bit faster. And so your timing signal, you want to adjust that so that you're feeding quicker and feeding your lengths. So you could see you're either feeding by number of seconds or of the length of the coil that you need to feed through. You set your position, you get everything set up, and you're ready to go. And so now suddenly in the pendulum motion, you've actually now increased the speed to 76 SPM, making the same parts. But that's I think this is the feature that everybody seems to be very familiar with, and it's pretty easy to do on maybe one of you already have a die that you've already built. So you look at those few examples, and from our standpoint, You know, when you're looking at servo press and thinking about how could I possibly employ this technology, you know, you start thinking more vertically, and maybe that's why a lot of the transfer manufacturers are becoming very popular, because you see it where you know, parts are being designed where you can do more in one revolution. You could start higher up in the stroke, having that energy to be able to come down on it and perform more operations before you actually reach a full cycle. And so what does that do? You know, it's allowing you to, maybe you've got progressive dies and you look at them and say, well, how can I take this progressive die and reduce the number of stages? It could be a current die that you already make. The one key thing to keep in mind is that, okay, for the most part, right, you should be able to run any die that's built for mechanical, a regular mechanical press, and a servo press, but it's not necessarily the same way around, right? So when you get into it, and you get into servo, you're in it, because you probably won't be able to back out of it without having to retool. So you know, you look at it, so you think vertical. What can you do? What can you be accomplishing in one cycle of the press? And again, it's, you know, wanted to reinforce of having the press manufacturer to be part of the process. Even if you do own a servo press, you go back to your supplier and say, we're going to be working on this new part, or you know, we'd like some assistance or recommendations, and I would expect that the manufacturer should be able to do that. So when we look at, you know, thinking vertical, this next video is exactly what we're talking about here. Reducing, I think in this scenario, the blank's already made, but we're going to basically take, you know, 4 stages down to 1. This is another example. This is a typical 0.4 deep draw material. By the way, this is Nader, if I didn't already mention that, in his shop in Sweden. So what's being explained right now is, you know, taking those stages down to 1, and then even in this particular example, I think it's important to know that where the die is actually set up on the press, it would be impressive. It's impressive to see that we've got this fully loaded on the right side of the press, and that's just kind of showing you some of the rigidity that the servo press should have in maintaining the precision, tolerance, in the off-center load, deflection, and such. So I think, you know, this is a pretty simple way of looking at how to optimize the tooling using the servo press. And then what we're, you know, a lot of those, you get into the you know, the part design and die design process, and thinking about the materials, and then thinking about lubricants and how they impact the formability. You're starting to, you know, notice, okay, there really was less lubrication used. In some instances, I know I have customers who said they don't have to use lubrication anymore to run the part. Just by being able to slow the press down and control it more, the material is able to flow, and you know, because of that, we get less gas coming off of the heat, and the part itself is actually not nearly as hot as it would be if you were doing this in a hydraulic press. Now, is there anything that you would like to add to the description of this die and this particular example and what was being accomplished for this part.
It's actually we get very flat in the side. Normally, if you do it in, you need to use a hydraulic press for this kind of deep drawing, and the temperature of the part when coming out from the tool, it's something like 80 degrees. But here we have not more than 30 degrees the temperature. It means we have the lubrication, and what we do here is we're going up and down a little, and then we make the lubrication with us, and with very little lubrication. So it's the thing, and we do it in one step.
Nader, you designed the previous die, right? As was it a 4-stage progressive die, and then came back and redesigned it as just one die set with the final draw, just basically, in one stage. Is that how you approach this?
Yes, but what you can do when you set up the tool and you testing the tool for deep drawing, in this machine you are able to drive the machine with manual hand control, and see what's happening, actually what's happening when you make your deep drawing. And you are able to make the program, in this case is free programming, to make the part in best condition.
Okay, thank you. Another example, and Seyi's probably used this ad nauseum. This was an example of a part that we had when we debuted our servo presses back at the FabTech Chicago show in 2011. And it's simply, another example of going vertical here, and forming pretty. This is about a 4-inch draw here. And we took this in our testing, looking at this stainless steel oil pan, running it in a conventional, I think this was a 600-ton mechanical press. Then we tried it in the link motion, and then optimized it for the servo press. So it's something that you could do maybe in a mechanical or link motion press. Is it going to be effective? Probably not without some additional tooling or a lot more control. In this example, what we're showing is, you'll see that there's we are using a hydraulic cushion here to kind of bind the sides and control that. But for the most part, within this one stroke, one cycle of the press, we're going to form this entire shape. So again, we see we've got the tonnage signature, and then we have the actual real-time profile of the part being made based upon the program. Just selecting from the menu of, holding 200 jobs, selecting from that menu. And now we've got our set points of what's actually happening here for this part. We are dwelling for about half a second, but it really is only taking 4 steps to create this rather not necessarily complicated, but a pretty good deep draw. So it's there's not a lot of effort going into transferring what needs to happen with the die and transferring it over to the program. So it comes out looking beautiful. Finally, kind of getting back to an earlier slide and dealing with the advanced high tensile strength steel. And I think at least one of the things that I read about is if you're dealing with these maybe these half shape or structural components, using flange dies and trying to overcome spring back by having some allowance to overbend inside the die and then doing a restrike. And what we're trying to do here is eliminate having to do that and controlling that spring back as it's being formed. Oh, darn it. Apologize for doing this over and over. So what we actually have here in looking at this profile, we're still starting up at the 250 millimeters. We start going down rather quickly down to 80 millimeters. Now I believe this is in a 10-step process, and I guess really where we're looking at the action happening here is when we get down to 10 millimeters above bottom dead center, then we're going to go up a millimeter. And that's really going to allow your material to, and this may not be the technical term, but allow it to kind of relax for a second until we then bring it down to bottom dead center. And that's where you're really taking out the spring back. So that's the press action without the piece in it. You do have these springs up here for supporting the material, and then your signature with the no load. This, oh, by the way, this is a high strength 590. I believe. I think that earlier when we first got right up here, this high tensile strength, it's 590 MPa. So we're starting to getting up into the, dual phase, and even starting to, certainly it's not trip material, but, we're getting into that type of hardness. So your final piece comes out with a perfect bend, and we're just doing that all within one cycle of the press. And so thinking vertically, thinking about how much you could do in one cycle, in maybe removing the spring back out of the material, and again, for the last time, just reinforcing to invite the press manufacturer, and I think that I know at least from Seyi's standpoint, we do have Nader, and then we have 2 design engineers in a Japanese design engineer, Taiwanese design engineer that will look at and help evaluate a part, or even help evaluate a current operation and say, well, how can this be optimized? And I think that can't really stress it enough that there is some responsibility from the press manufacturer to try and help you guys get more educated in what to look for when you're optimizing it for the servo press. Because again, without owning one and not having the opportunity to play around, nor maybe the resources or time, you want to be able to look to maybe some experts, and I think that those experts may be with the manufacturer. At least it would be with Seyi, and that's regardless if you're a customer or not. So that is a pretty much a basic approach to the things to look for, and coming from a part design and a die design standpoint with using the servo press. At this time, we'll open the floor up to any questions. Certainly it's difficult to get into very detailed information in the time that we have. If you do have a question that goes beyond my ability, Nader's here as well as a tool and die maker to help answer those. So thank you very much.
Great, Randy and Nader, thank you very much for your presentation. We do have some time for questions. Go ahead and use that control panel to fire them away. Randy, the first question we have is, can punching be incorporated into a progressive draw die and still run the press in that pendulum mode? Can you punch in that mode as well?
Nader, from your experience, have you run into that or would be able to answer that question?
If I understand correct, you mean if it's possible to make a vibration in pendulum motion, or?
Well, the question was punching. If you're operating a draw die, a progressive draw die, and you need to perform punching operations in the cycle, can you do that and still run in the pendulum mode? And the person that asked the question, if I'm not explaining it correctly, go ahead and rephrase it. Does that make sense?
Yes, you can do it in pendling operation.
Okay, so the answer is yes. Right. Simulation, what type of experience have you had, either one of you, with simulating press operation, with a servo press at the design level?
For a moment, I don't know about any simulation program. Maybe it's coming in future. But the servo technology is very new, and it's a few tool makers know about the technology.
Nader, did you gain your experience using the servo press simply by having the servo press and trying it out, or how did you move from a kind of a traditional way of thinking with the design, or even if you don't have the opportunity to simulate, what other options are there?
The servo press is something I think every tool maker dreaming about, to be able to do more and like deep drawing. It in one step. It's something everybody dream about, and have the vibration, the possibility to have the vibration is something new, and it give us a new possibility. So I think it's very important for tool makers to understand what possibility they have in this machine. So for us, it's important to have a servo press, and we make. I think we make several different kind of testing. We manufacturing new tools, testing tools, and we testing different kind of solution ideas from us and from our customers.
Is there an opportunity to eliminate secondary trimming due to the control that you get during forming? Can you eliminate trimming?
I don't think I understand correctly your question. I'm sorry about it.
Is it possible to eliminate the secondary trimming operation because you get more force control?
Yes, it's possible. You can, but you see when you make the program, you can stay in which position you want, and it means you can have a second motion from the side. You can punch some holes or something, do some bending in this position, and run the press to the bottom. So it's you can do much more in one step, or more few steps. So I think you can decrease several steps in progressive tools. Yes.
And I've seen it a couple of ways where, even using it as part of a transfer stage, where you have a trim operation, or I know with one customer forming the part, and then at the very end they kind of I don't know if this would be the same thing, but they'll have a like a cutting stage right at the bottom of the press, right at the bottom of the program, and that's where it took them a long time to figure out the breakthrough point without getting the the edges all roughed up, and that's what they were really trying to accomplish. This happened to be on a piece of stainless steel. But what happened is that they were actually able to, it's a regular die they had always been running, and they put it into the servo press, but the customer, I think they needed to change the stainless steel and so they were hoping they didn't have to retool. Mm-hmm. And it turned out by taking, getting right at the bottom before it cuts off, slowing it down significantly, but still being able to have the energy to break through and keep the edges fairly smooth, and reducing the amount of the grinding that they had to do afterwards.
Okay. Have you seen anyone produce fine blank parts using a servo press?
Is this question for me, or?
Yeah, well, I think for you maybe not. Or I have not seen it in. No, I have not.
Okay. We do it in Sweden, and we make several parts, fine blanking parts in our servo press.
Excellent. Okay. The question is, in the pendulum mode, you're running so much faster. What's done to minimize, the tendency to wear the punch that much faster, since you're, repeatedly entering and exiting the part that much, at a higher rate? Are you seeing the need to use different types of tool steels, for example, or coatings, or how do we battle excessive wear on the punches?
Nader, is that something you could answer? I mean,
I think, yes, I think the important thing is to think about is you are able in this kind of machine to do more smart program. It means you can make much faster program, and you can have much more effective production. So it's the biggest things. If you want to have higher speed, I think it's better to use a high-speed machine. But in high-speed machine, you are not able to control the whole process.
Mm-hmm.
I think we will make some tests in our SD 1200 in Sweden, and we have one progressive tool with thickness was 1 millimeters, and our speed in the machine was 280 in minutes, 280 stroke in minute. So it means you can have a very high speed in this machine, in this kind of machine, but we had only, I think it was only 10, 15 millimeters for a stroke in pendulum motion.
how does that impact, Nader, how would that impact the tool life?
But of course, we didn't do a lot of tests, but some tests we did with, I think we made 1.5 million pieces, and we see we can decrease the maintenance with 40%. So it was very, very good.
Right. All right, so we've got one last question, and then we're going to have to cut it off. Is there any benchmarking available for servo press design concepts? And I don't know if that means part design, die design, or both, but is there any benchmarking available for this type of thing, or are we too early in the game here to have that type of thing available? Are you aware of anything, Randy?
I'm not aware of anything. I think that's a great question that, maybe press manufacturers as a whole group, and maybe it's a charge for PMA to try and help develop those benchmarks in kind of an objective way, mm-hmm. using the resources from the different manufacturers and
right.
Testing that's been done.
Yeah,
that sounds like a good revenue opportunity for PMA.
Makes sense. We'll take that on. Randy, do you want to tease the attendees at least a little bit about what you're going to be presenting in Nashville? I know it's not going to be a repetition of what we saw here today.
No, we're going to focus in more a little bit on the vibration mode, because the Seyi service center is so close. We want to also extend the opportunity to have people come out there to it's about an hour away from Nashville, and have them actually touch and feel and see how these these concepts are put into reality. But for the presentation itself, we're going to kind of drill a little bit deeper with the vibration mode. It it's becoming a little bit popular, and we want to be able to kind of demonstrate its capabilities a couple different ways.
Great. Look forward to that. Okay. Well, with that, I want to thank everybody for attending today's program, and especially thank Randy and Nader for their presentations. We hope everyone found it to be a valuable experience, and please remember that an archive of the webinar will be up on our website soon, and you'll receive an email from us when it is up on the site. Also, make sure to visit metalformingmagazine.com/servo and register for next week's webinar, and then also check out the live event, which is coming up in Nashville on October 7th. Again, thank you for attending. I hope everyone has a great afternoon, and you can close your browsers now.
Thank you.